Hello, my name is Gareth Davies and welcome to the Kiwi Astronomers. I have with me today, as usual, John Drummond, who's a fellow of the Royal Astronomical Society of New Zealand. He runs Gisborne Astro Tours and he is the IAU National Outreach Coordinator for New Zealand. And I know that because I've got it written down here in front of me. John, good afternoon. How are you?
Hi, Gareth. Good to see you.
Yeah. How are things in sunny Gisborne?
Yeah, no, sunny. It's a beautiful sunny day today. Had a surf this morning, so I'm all happy.
Wow, you lucky thing. So you're not in lockdown, obviously.
No.
All right. So today, of course, is a Vaxathon in New Zealand.
Yeah, Super Saturday.
I've been watching it on the television.
No, I haven't.
Thank you very much for your vaccination. Thank you very much. Thank you very much. Thank you very much for your vaccination. Remember the good old days of the telethon?
Yes, I do. Yep.
Why did that stop? Do you remember?
Don't know.
They were always raising gazillions of dollars and then suddenly they stopped, which I don't quite understand, but still the Vaxathon seems to be going well. Over 100,000 people vaccinated today.
Yep.
What I'm wondering, what I don't understand is why they waited so long. But anyway, why should I ask that question?
Yeah.
All right. So today we are going to talk about Saturn. And John, tell me something about Saturn that I don't know.
Okay. Well, you probably know, Gareth, that today is Saturday, and we get our name for Saturday after the planet Saturn. So, of course, we had Monday after the moon, Moon Day, Sunday after the sun, and so on. So, yeah, Saturn is the day that we celebrate, the planet we're celebrating today. Saturn's the second largest planet in the solar system. It's the planet that most kids know. Ask a child to draw a planet, and they'll probably draw a planet with rings around it like Saturn. So it's the second largest planet in the solar system. It's a beautiful planet to look at. In fact, last night I was out with my telescope looking at it, and it was probably about 250 times magnification, and I had it zoomed in quite well and could just see some really nice features on the surface and also on the rings, and also Titan, one of the moons of Saturn, sitting beside it. So yeah, it's really beautiful.
Didn't Galileo see it and it looked like he had it had ears? Didn't he think it was a strange planet with ears?
That's right. Because of the telescope that Galileo had, it didn't have the resolution that later telescopes would have. So when he saw it, it looked like an elongated planet with ears either side. He couldn't actually discern it as rings. So it wasn't until 1655 when Christian Huygens, I believe it was, he was the one who actually had a better telescope, and with the better resolution was able to see that they were rings going around Saturn.
Christian Huygens, didn't he invent the grandfather clock?
Oh yeah, that's right. A lot of these old astronomers were very much tied up in other aspects of science and technology too.
Yeah. Seems a bit strange that he invented the grandfather clock, don't you think? I'm a big fan. I don't have one. I used to have two, but I left them back in Britain. But yeah, well, there you go. Christian Huygens, yeah.
Back in the old days, every observatory needed a reliable clock. So
of course. Yeah. All that longitude and all that stuff as well, right?
That's right. Yeah.
Yeah. Clockmaking was very important. So anyway, Huygens spotted they were rings, did he?
Yes, he did. Yep.
What about Cassini? What about Cassini? Who's he?
Cassini is an astronomer, later astronomer, who saw the rings. That in the rings there was actually a gap between the rings. When you're looking through a telescope, you'll probably see two main rings with a gap between them. Ring A, which is on the outer edge of the rings, then the Cassini gap that Cassini discovered, and then the B ring coming closer to the planet. And in fact, there's a C ring too, which is even closer to the planet, but that's harder to see. It's not as reflective, not as bright as the ring A and B.
Right. But you were out watching it last night.
Yeah. So easily saw rings A and B and the Cassini division between them, and the features on the planet. I mean, Saturn doesn't have nearly as many features as, say, Jupiter, with the belts going across it and the zones. And last night, when I was looking at Jupiter, I saw the Great Red Spot and things. Saturn is more sort of more neutral as far as the surface features, but it does have them, but they don't stand out as much as Jupiter.
Well, you were seeing the big red spot. What the storm on Jupiter? What scope were you actually looking through?
Last night I was using a half meter 20-inch f3 f3 telescope, but I had a 2 times Barlow and a 17 mil eyepiece, and so it worked out about 250 times magnification.
So it wasn't like your normal looking through an 8-inch Dobsonian then?
No, a little bit more magnification, yeah. But I mean, the 8-inch Dobsonian can zoom in if it's a very steady night. You can put a Barlow there and like a 10 mil eyepiece or whatever. Problem is, when you do zoom in of a Dobsonian, because the Earth's rotating, the target will move out of the field of view fairly rapidly.
Yeah. I mean, I've never properly been able to spot the Cassini division through my 8-inch Dob, and by the same token, I've never been able to spot the Great Red Spot either on Jupiter.
Oh, you'll have to come to a Gisborne Astro Tour, Gareth.
Yeah, it must be my eyesight. I don't know. Something's wrong. But anyway, so tell us some of the facts about Saturn. How far away? How big is it? How long is a year? How long does it take you around the sun? All that kind of stuff.
Right. Okay. Well, Saturn takes 29.4 years to go around the sun, so roughly 30 years to go around the sun, as opposed to Earth, which takes 1 year to go around the sun.
Yeah.
Jupiter takes about 12 years. So Saturn, being further out from Jupiter, roughly double the distance from Jupiter, takes a lot longer. So about 30 years to go around the sun.
Right.
1 day on Saturn lasts about 10 hours, 13 minutes at the equator. At the poles, it's actually 10 hours, 39 minutes. So there's a certain amount of rotational differentiation between the pole and the equator.
Wow.
Saturn's basically a big gas ball, a big ball of hydrogen and helium, and it's not gravitationally large enough to compress the hydrogen and helium down like Jupiter. So because of that, it's actually it's not a very dense planet at all. The density is about 0.7 grams per cubic centimeter. So remember, water is 1 gram per cubic centimeter. So that means that if you had a swimming pool large enough and you put Saturn on it, Saturn would actually float in the swimming pool like a big beach ball, basically.
Oh, wow. I'm finding that hard to imagine, but I'll take your word for it.
Yeah.
And have we sent many spacecraft there to check it out?
Yeah, so a lot of our knowledge about Saturn came from the probes. So in 1979, Pioneer 11 went past it and took some photos. And with later probes, the cameras got better, the resolution got better. So Voyager 1 went past in 1980, Voyager 2 in 1981, and then the Cassini space probe reached Saturn in 2004 and did multiple orbits of the planet, and got some fantastic images of it. And of course, it had a whole suite of scientific instruments to test the gravity of it, magnetosphere, and so on. So yeah, a lot of our knowledge has come from those probes, and they actually put a probe on the other side of Saturn from the sun, and using a thing called the forward scattering of light, it actually picked up all these rays and maybe additional rings and so on. It's a very famous photo, and there's a little dot in the rings, and that dot is Earth, taken from the other side of Saturn.
Was that another probe, or was that the Cassini?
I think that was the Cassini probe that took that photo.
Didn't it have another one that dropped down onto Titan?
Yes, so they sent a probe down to Titan and got some fantastic images and the data. I think it lasted for about an hour when it landed on Titan, as far as sending temperature and other readings back. They found on Titan that it's actually has large lakes. I mean, these lakes are larger than Lake Superior in the United States. One of them is called Kraken Mare, and it's a really large lake. It's not liquid water like we have liquid water. It's more liquid methane. And with the winds on Titan, it actually makes waves. So they've detected that there are waves on this lake on another world, which makes all surfers excited.
So how many moons or satellites has Saturn actually got?
That's the $1 million question. But as far as discovered satellites that we know of, it's in the high 80s. So I think the last count I read was about 88 satellites going around Saturn. Titan is the largest satellite going around Saturn. It's actually between Mercury and Mars in size, so it's actually larger than Mercury. It's about 5,100 kilometers across, and it was discovered by Christian Huygens in 1665. And so that's that satellite. Saturn has other very interesting satellites. One is called Mimas, or Mimas. I'm not sure how you say it. It looks like the Death Star in Star Wars. So it's basically a ball with a giant big crater sitting on it, like the Death Star.
Wow!
So that's quite a famous one. It's a very small moon, but it looks cool. And then
you can't see it with a telescope, though, right?
Oh, I don't know offhand. Don't know.
Yeah.
Another very interesting moon going around Saturn is Enceladus, and that's actually when they were photographing it. There was a scientist called Caroline Porker, and she actually happened to just look at the images just as everyone was going to bed, and she saw these interesting plumes coming out of it, and they realized later that Enceladus has these cryovolcanic activity on it, so it's spewing out basically salt water into space. So that's really exciting, because Enceladus, as it goes around Saturn, there's another moon, I think it's Dione, and that's as Enceladus comes between Saturn and Dione, it actually gets stretched by the two and then possibly squeezed back as it goes out from between the line of those two objects, and so is making these cryovolcanism events on it. So there's possibly a large substantial ocean underneath Enceladus, under the ice and so on.
But no sign of any life.
Not that we know of. Astronomers would love to send a probe there to actually be able to go into the water and test it for microbes. There's other satellites out there that would love to send probes to, like Ganymede, and a few others, basically where we believe there is a liquid ocean underneath a solid ice covering.
Is there any reason behind the names? They don't seem to have any kind of link. You know?
Oh yeah, no. Some of them were named after deities. Yeah, quite a few were.
Are they all deities? Are they?
Yeah, lesser known deities and so on.
Titan's not a deity though. Weren't they some bad dudes?
Yeah, well, you know what I mean. Greek mythology and so on.
Yeah. And what about Saturn itself? Where did that name come from?
It's named after the Roman god of wealth and agriculture.
Oh, I'm glad you had the answer to that, because if you didn't, I read it this afternoon. I was going to pop in, but
okay, sorry, mate. In the Greek, it's known as Kronos.
In
the Greek,
yeah,
Saturn is known as Kronos.
Kronos.
Yeah.
Oh, that's quite a. It would be
Kappa,
Day then, wouldn't it?
What's that?
Monday, Tuesday, Wednesday, Thursday, Friday, Corona Day, Sunday.
Yeah, that's right.
Yeah. So
Yeah, so Saturn actually has some interesting features. It's got incredibly strong winds that blow around the equator, roughly at about 1,800 kilometers per hour. So faster than Jupiter's winds, but not as fast as Neptune's winds, which is kind of strange because you'd think that Jupiter, being closer to the sun, receives more solar energy and therefore would have stronger winds and so on. But no, Saturn has actually got the stronger winds. And Saturn, being twice as far from the sun as Jupiter, receives a quarter of the amount of solar radiation from the sun as Jupiter does. But
wouldn't it be wonderful if Jupiter and Saturn were reversed? Whenever I look up at the night sky, I always think, wow, imagine if they were in reverse positions, how wonderful Saturn would look if it was like, that much closer, and we'd be able to see so many more features, wouldn't we?
Yes, you'd probably see some more features, but as far as Jupiter's got more features in the clouds.
That's true. I forgot about that. It's got, although we would see more moons, right? We would see more of Saturn's moons if it was closer.
Yeah, because they're closer, possibly. Yep, that's right.
And of course, Titan's the second largest of all the solar satellites, right?
That's right.
Yeah.
After Ganymede.
Yeah, it's quite clear, obviously, when you even through my 8-inch, you can always spot Titan. There is another bright light when you look at it, but I'm thinking that might be a distant star. Am I right about that? Rather than a satellite?
Yeah.
Only sometimes.
Yeah, it can be chance alignments of stars and so on. But if you crank up the magnification, view it when there's no moon in the sky, then you can probably pick up some of the fainter satellites, besides Titan. Just don't ask me them offhand.
Right. So of course, Saturn was part of the Great Conjunction, right? Last Christmas.
That's right. On December 22nd in 2021, Saturn and Jupiter were in the same telescope field.
Yeah.
So that was exciting. We had over 3 nights. We had probably about 200 people come out to Gisborne Astro Tours to have a look at the two, and they really did look amazing to see them both sitting side by side in the same telescope field.
Yeah, we had a few on Waiheke. We had a couple of nights on Waiheke Island with people coming out. We had over 100 people one night.
Right.
But the weather wasn't the greatest in Auckland. But I do remember telling everybody that they should enjoy the rings of Saturn, because slowly but surely the atmosphere, the gravitational field of Saturn was pulling in those rings, and that eventually those rings will disappear.
Yeah, and in 2025, so in 4 years' time, they will disappear as seen from Earth.
Yeah,
they'll be edge on.
Is that right? In how many years?
In 4 years' time.
Oh, my story was, of course, that they will disappear totally. But then I tell them not to worry, you won't be for 300 million years.
Yeah, that's right.
They didn't have to rush out. But that's right. Once every certain period, 14 or 15 years, right?
Yeah, that's right. Because Saturn is tilted on its axis, and so sometimes from Earth we're actually looking down onto the rings. Sometimes we're looking from the other direction. We're looking into the South Pole and polar region, and we're looking up into the rings. But when the rings actually become edge onto us, then they disappear, because they're only probably about 10 or 20 meters thick, the rings. I mean, they're 274,000 kilometers from edge to edge, which is almost the distance from the Earth to the moon, which is a large area. But when you look at edge on, very thin. So in 2025, between now and then, keep an eye on Saturn. You'll slowly see the rings get less prominent until they tilt, until they edge onto us, they disappear, and then after 2025, they'll start reappearing.
So they'll get so everybody going, wow, because, as you know, when you show people that Saturn for the first time, they go, wow. And frankly, when you see Saturn for the second time or the 10th time, you know, even the 50th time, you still go, wow, because it looks so amazing. But suddenly people are just going to sort of say, oh, I thought it had rings.
Yes, yeah, that's right.
Oh,
So I mean,
that's
it
very disappointing.
won't be long until the rings start coming out as a very thin line, and then further and further, and get larger. It's quite interesting, Gareth, that if you added all the material of the rings together to make one moon, it would make a satellite of about 100 kilometers in diameter.
Is that amazing or not?
Yeah, yeah. I mean, last night I had someone at the telescope tour, and the person said, gee, if you added all the ring material up, because we're looking at Saturn, if you added all the ring material up, it must be a large body. And I said, no, it's only about a diameter of about 100 kilometers.
No, that's
So
what I
not
thought.
a very big
It's not
object.
much. It's not much, right?
Not much, no.
Yeah, that's
no.
what I thought.
It's just spread out. Most of the chunks in the rings range from, you know, dust-sized particles up to sort of like 5 or 10 meters. But most of the material that the probes found was around about 10 centimeters across.
By the way, there are some moons within the rings, right?
Yeah, there are. They're called shepherd moons.
Oh.
Yep. And some of them have an effect that they're actually carving out gaps in the rings. Like in the A ring, there's a thing called the crepe ring, CREPE. And one of the moons is actually...
in crepe that you eat?
Yeah, that's right.
Oh.
And one of the rings is actually affecting the rotational velocity in that ring, slowing down the outer part, speeding up the inner part of the A ring, and that's causing a division to occur of I think it's about 50 kilometers or so across, or so. So yeah, so these shepherd moons do have an effect on them. In fact, there's also rings out in the outer parts of the rings where there might be cryovolcanism and so on, which is spewing out material and feeding the rings.
What was that word?
Cryovolcanism. So it's like volcanism, but instead of lava...
Scrabble. You should be playing Scrabble.
Yeah.
That's like a 500-point word, that one.
Yeah, that's right. Yeah. No, so instead of spewing out lava, you know, as we know of Hawaii and so on, it actually spews out basically liquid, volatile materials like liquids, waters, and so on.
Now, tell me something, John. For those who are looking on YouTube, there's a wonderful picture behind you of Saturn. Oh, wow! It looks, yeah. And did you take that by any chance?
I wish. No, I believe that. I think that's
the correct answer is yes.
Yeah. No, I can't lie on YouTube,
on my iPhone.
Yeah, I'm not sure. I just got this a couple of seconds before we started. It might be Hubble or it might be a probe picture. I would say it's probably a probe picture from looking where the shadow alignment is.
Oh, yeah.
It must be.
That's a good point.
You can see on the left side of the image that there's a lot of shadow, and from Earth we can't see that shadow from. I thought
that was something growing out of the side of your head, but now I realize it's not.
Yeah.
But anyway, so you being an imager, you must have got some pretty nice images of Saturn over the years.
Yes, I have. I must admit, planetary photography is something I never really got into. I'm more deep sky, comets, asteroids, galaxies, and so on, nebulae. Planetary imaging requires a webcam, basically, where you take a whole heap of photos, like many hundreds of them over minutes, and then you put them into software. It picks out the best images and then stacks those images to create the master image, and then you process it. I must get into some webcam photography of planets.
Because when I last saw you in Auckland before the lockdown, you gave me all the simple instructions on how to set up a camera to take pictures of the moon and what have you.
Yeah,
that seemed relatively straightforward, right?
Yeah. I mean, you can get images through a telescope, like even your Dobsonian. You could put your cell phone up to it and get a snapshot. But as long as it's not a long exposure and Saturn will move during the exposure. I mean, last night somebody got a nice photo. They put their cell phone up to the eyepiece and got a nice photo of the moon, and they were really happy about that.
I
So
find
it
that
can
a
be
very
done.
hit or miss thing though with my iPhone. I've got some contraption that I bought and I stick it on the end and it's really annoying. And I'm trying to get my iPhone and they didn't help by putting all those extra lenses on the iPhone, to give you, I mean,
Oh, yeah, yeah.
it's wonderful in the day. It's wonderful for normal photography, but once you try to use it for the moon and what have you, it's the most annoying experience ever.
Yeah, yeah, yeah.
But anyway, it's worth telling everybody that they should get out now and enjoy looking at Saturn if they get the chance, because very soon, 4 years' time, is that right? We're going to see no. Do you mean we'll see absolutely? It'll look just like Jupiter,
Yeah, pretty much. Just a
only not
bland,
so
but it'll
good.
be bland. It won't have the features of Jupiter.
Oh God, isn't that terrible?
Yeah. And
Thanks
also
for
bear in mind that now's the time to be looking at Jupiter and Saturn, because slowly they're edging towards the sunset.
yeah,
And
yeah.
so probably it'll be, I don't know, I must look it up, but it's probably around about January. They'll be too close to the sun. They'll be on the other side of the sun, so we won't see them until the morning sky. And
How long will we have to wait? It's an awful wait, that
well,
isn't it?
last year they disappeared around about January, so it'll sort of be roughly around about the same time, maybe a little bit later,
That's a
February.
terrible wait. That's a terrible wait.
Yeah,
Anyway, okay, well that's pretty good. I hope people have learned something about Saturn. Certainly to get out there and watch it.
yeah.
There is one thing that before we wrap that I wanted to tell you about. You know about, of course, about the International Dark Sky Association and IDA, and work it's doing internationally to try and save our skies so that we're able to go out and enjoy dark skies rather than the awful urban scapes that the vast majority of the people in this world now have to put up with. And every year, I don't know if you're up to date with this news, they give a Dark Sky Defender Award out. You know about that? Heard about that?
No,
The Dark
no, I
Sky
haven't.
Defender Award. What they do is they give one to, it's given to individuals and organizations in recognition of their efforts to promote and advance the mission and programs of IDA to preserve the night skies on each of the 6 inhabited continents. So the penguins don't get any in the South Pole, but because they'd be winning it every year, of course. But they give one, this year there's one that's gone to Tanzania, so that'll be Asia, I suppose. No, Tanzania, Africa. Malaysia, that'll be Asia. Slovenia, that'll be Europe. USA, somebody in the USA has got one. Somebody in Argentina has got one, so South America. And then, of course, there's Australasia. And somebody in New Zealand was awarded one this year.
Oh, wow.
Yeah,
Okay.
amazing, eh?
Yeah.
And do you know who that person was?
No.
Me!
Really, Gareth? Oh, classic.
Yeah! Can you
Well
believe it?
done.
Can you believe
Awesome.
it? Dark Sky Defender. I'm just going to rip open my shirt. No. Because of lockdown, I haven't had the chance to get that. What have I got under here? Oh, nothing. Oh, a polo shirt.
This is a family show, Gareth.
Oh, so yeah. So how about that?
Oh, well done, Gareth.
Isn't that
That's
good?
really good.
I'm really pleased.
neat.
And it's not like I haven't done my bit for dark skies
Yeah, that's
around
right.
the country and on Waiheke Island in particular, when I'm allowed to go back there.
Jeez, hey, that's great.
So yeah, I was really pleased about that. So
You'll have to send me the details so I can put it in the next Royal Astronomical Society of New
yeah,
Zealand, keeping in touch.
I can also send you some signed photographs.
Yep. Okay.
Because I'm sure they're going to be in big demand.
Yeah, oh, definitely.
Dark Sky Defender. There you go. So
Oh, well done, Gareth. You deserve it.
Thank you.
All the work that you and Nalani do. Well done.
Thank you to the International Dark Sky Association in Tucson, Arizona. And
Yeah.
if anybody wants to read about it, you can go to their website. And there's a picture of me standing in front of my equatorial mead, which happens to be located on Stony Batter on the eastern end of Waiheke Island, in one of the ammunition buildings that they built in 1944 to repel. I wouldn't say who they were, but there were people planning to invade. It's not good to say these days, but there was a nation planning to invade New Zealand, and we had some guns there, but they never fired in anger. But in the place where all the shells were stored, or certainly where the people waited to go and get the shells, that's where my mead is. And at some point in the future, we hope to bring it into the light of the night and let people see the dark sky there. Anyway, that's me standing in front of it, in case anybody goes there and looks at the picture. All right, enough of this wittering on by me. Thanks, John. We will talk again soon about a suitable topic, and I'll play you out with our favorite song.
Okay. Thank you, Gareth.
Take care. Bye, man.
See you, mate.
Take me to Callisto so I can see the stars. I want to view the Milky Way from a terraform base on Mars. From a terraform base on Mars. From a terraform base on Mars.